we've talked about reflections, we've talked about translations. Next thing we're going to talk about is rotations. So a rotation is a type of transformation that turns a figure around a given point, which is usually the origin. So the origin, if you remember from your vocab, is the point 0, 0. So it's right where the two axes, x and y, intersect. It's usually around that point. So it turns a figure around a given point and at a given angle. And you'll see, most basic angles and rotations that you'll be asked to do, and how that changes a figure and how it changes the coordinates of a figure. In your packet, you should have this worksheet that you're going to complete after you do the activities. What we're going to do is, this is going to be our example. This is going to be our table about how the figures change. So these are going to go on one page, just like the reflections handout went on one page. And then these 3 problems will go on the left side of the page. But we're going to do this one as an example, and you'll be doing these 2 on your own. Okay. So what you can do now is just cut that, and we'll leave that one for later, but cut this box out and this box out. Once you've cut everything out, your book should look like this, with your definition of what a rotation is, our example here that we're going to do in just a moment, and then the table which we're going to fill out with our example. Then this will become our first example problem, and you'll do these 2 on your own as practice and have your teacher check your answer. But first, let's dive into what happens when you rotate this point right here. 90 degrees, 180 degrees, 270 degrees, and then 360 degrees. And all of these rotations are going to be about the origin. Now, in my table, I've got my x, y. In general, what happens to the x and the y when we make these rotations, and then what happens when I do this single point as an example. So this point that we're going to be rotating, we want to put the coordinates in here, and we're going to put them in as 2, 5. So we start out with it being 2, 5. So my first rotation is 90 degrees clockwise, and it's all about the origin. So what I'm going to do is I'm going to use my transparency paper, and really this is the best way to do rotations, to actually draw them out, is if you have transparency paper, you're going to copy down the figure, which is just a point in this case, and you would label the point. If this was labeled P, we'd write down P, but in this case our example is not labeled. And we're also going to shade over and copy down the axes. Now, we're asked to do a 90 degrees rotation about the origin. So I'm going to stick my pencil on the origin, and I'm going to rotate this figure 90 degrees. So 90 degrees, when you think of 90 degrees, I think of a square. Like the corner of a square is 90 degrees, which is actually this symbol here. A 90-degree symbol looks like a little square. So when I rotate this clockwise, which is this way like a clock, 90 degrees, I'm spinning it just one turn around the origin and then lining up the axes again. So that point comes to here. And so that would be a 90 degrees clockwise rotation. I also want to point out that 90 degrees clockwise is the same as 270 degrees counterclockwise. And let's test that out. So counterclockwise, we're going this way. 90 degrees is one turn. Another turn is 180. Is 90 and 90 is 180. And then another turn is 270. So we still get to that point. Okay, so 90 degrees clockwise is the same as 270 degrees counterclockwise. And let's look what happened to our point. So from 2, 5, it went to 2, 3, 4, 5, negative 2. So a 90 degrees rotation, 2, 5 went to 5, negative 2. Do you see a pattern between this point and this point that we could generalize for x and y? So think about that pattern. It's one of the harder patterns to think about. So what you should have come up with is that the x and the y flip places. So if you rotate 90 degrees, here the 2 came first, now the 5 comes first. So y comes before x. They flip places. Now what else happens? Because we went from 2 to negative 2, the sign on the x changed. So this becomes a negative x. And that's what happens when you rotate 90 degrees clockwise or 270 degrees counterclockwise. The numbers switch spots, okay, and the sign on whatever the x value was changes. Now let's look at a 180 degrees rotation. I'm again going to copy down my figure, which is already done for me, and it's around the origin, so I put my pencil on the origin, and I'm going to spin 90 degrees and then 180 degrees. So my new point's right there. And if we're talking about the difference between clockwise and counterclockwise, if I go the other way, 90 and 180, I get to the same spot. So really, 180 degrees clockwise, 180 degrees counterclockwise, it's the same, and it gets you at the same spot, as the same number. So generally, if you're given a question that says rotate the figure 180 degrees, they're not going to say clockwise or counterclockwise because it doesn't matter which way you go. Okay, you always spin to the same point. And let's take a look at how this coordinate changed. So we went from 2, 5, and now it's at negative 2, negative 5. And again, we're looking for a pattern. So from 2, 5 to negative 2, negative 5. So what you should have come up with for your pattern is that the x and the y, they don't flip places. What happens is they both change their signs. So negative x and negative y. So 2, 5 became negative 2, negative 5. And that point was for 180 degrees clockwise and 180 degrees counterclockwise. So I want you to mark that down on your paper as well. Our next rotation is 270 degrees clockwise, which is the same as 90 degrees counterclockwise. Again, I have my point. It's already traced. I'm rotating about the origin 90 degrees, 180 degrees, and now 270 degrees. So that gets me to this point here. Okay. And it's important to note that 270 degrees clockwise would be the same as 90 degrees counterclockwise. And now we want to label that this was 270 degrees clockwise, which was 90 degrees counterclockwise. And our point went from 2, 5 to now negative 5, positive 2. So again, we're looking for a pattern. And what you should have found for your pattern is 2, 5, negative 5, 2. So these numbers switch places. So again, it's going to be y and x. But which one changes sign? So the 5 started out as positive, and the 5 was the y value, and then it became negative. So if you go 270 degrees, the y changes sign. What I find is the most common mistake is switching these two up. So if you're going either 90 or 270, they're both going to flip places. The numbers are going to flip-flop. Okay? What's important is which one changes sign. And the thing about rotations, it's almost, unless you're going to be doing it with a transparency paper, if you happen to have one by hand for any apparent reason, unless you're going to use that, you've got to memorize these formulas. They flip spots, but if it's only 90 degrees, the x changes sign, and if it's 270 degrees, the y changes its sign. Okay. For our last one, I want you to do that one yourself. What happens when you rotate it 360 degrees? What do you think happens to the point? How does it change? So I want you to write the point and then the general formula, like we wrote these 3 general formulas. And when you have your teacher check your answer, have them check this one as well. For this problem, we're asked to rotate triangle JKL 90 degrees clockwise about the origin. And so normally you're not going to be given this table. You're going to have to write this table, which is actually what you're going to do for number 2 and then number 3. But I wanted to set up the table ahead of time just to save some time. And what we're going to do is we're going to fill this out together. So let's pretend that I didn't have any transparency paper and I had to use the formulas. I want to look at my notes and think about what is a 90-degree rotation clockwise about the origin. What is the formula for that? So I look at my notes over here, and it's that the y and the x switch spots and the sign on the x changes. So I'm going to show that in my table. And I'm actually going to color code this. I just decided to make it easier to see. So we're going to start with x in blue and then y in red. And how they change is they both flip places. So the y is written first. Okay, but the sign on the x changes, so I'm going to make that a negative symbol. And now we're going to write down the coordinates for J, K, and L using our colors. Okay, and we're going to write how those change. So I've written down in color the coordinates for J, K, and L. So J is at 1 on X, 3 on Y. So 1 in blue, 3 in red, 1, 3. K is at 3, negative 2. And L is at 1, negative 2. And now we're going to say how they change. So they switch spots, and the sign on X changes. So J, the Y now is written first. The X is the second number, and it changes its sign, so it goes from positive to negative. So my new J is going to be at 3, negative 1. So that's 1, 2, 3, negative 1. That's my new J. We'll call it J prime. Okay, and it's okay when you rotate a figure if it goes into itself. It actually happens quite often. When it does happen, it's helpful to use a different color, which is what I'm going to do. When I start to actually draw in my new triangle J prime K prime, L prime, it's going to be in blue. Now let's look at how K changes. So again, the Y comes first because they flip spots. So -2 now comes first. And the sign on X changes. So from 3 it goes to -3. And that point is -2, 1, 2, 3, -3. And that's the new K. Call it K prime. And then L, the flip-flop places. -2 comes first. The sign on X changes, goes from 1 to -1. So my new L is at -2, -1, -2, -1. Call it L prime. And so there is my new triangle, JKL prime. I can color that one in blue, so it rotated into itself. Now, if you happen to have transparency paper, like I'm going to show you in a second, we can prove that this is in fact a correct rotation. And if I have transparency paper, I only need 1/4 of that sheet that's by the milk crate. I'm going to first draw my axes, so I know to line things up when I rotate, and then I'm going to draw in J, K, L. And it's really important to remember to label your points, J, K, L. And so if I was translating it, I would just be sliding it around. But I'm rotating it 90 degrees clockwise. So I put my pencil on the origin, and I spin it 90 degrees, and you can see that not only do things line up to the blue triangle that we just colored in, but the new points match too. This was the new J, the new K, the new L. So I want you to do exactly this process for triangle ABC, but you're going 270 degrees clockwise. And lastly, you're going to prove that this is a 180 degree rotation about the axis using the table like you did above. After you're done with that, you'll have your teacher check your whole page of notes, and you can move on to the practice problems. And that's it for rotations. Only one more transformation left. That's next, and that's dilations.